What's up, scholars, and welcome to Pre-Calculus! Today is our very first lesson, Unit 1.1, and we're going to be talking about domain, range, and interval notation. Now, these first two, domain and range, you've talked about definitely before. Interval notation is gonna look a little different, but it's beautiful. You're going to love it. So, let's remind ourselves, what are domain and range? The domain of a function is all the possible x values. All possible x values. And if we think about on a graph, the x is in the left and the right direction, so we could think about domain as going how far to the left we go and how far to the right we go. And range, my paper's moving everywhere. Range, you might have guessed, is going to be all possible y values. All possible y values with a V. V-A. There you go. All possible y values. Domain was going left and right. Range is going to be going up and down. Up and down. Simple as that. All right, let's do an example. So let's draw a graph. Get our x and y axis on here. We're going to make this pretty tiny. Let's go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay, great. Let's put a closed circle. So you're going to fill it in right here at -3, -2. -3, -2. And let's put an open circle over here at 4, +3. 4, +3. And we'll do a squiggly line because it totally doesn't matter. And just so we have this labeled, I'm going to say this was at -3, -2. That's where that point was, right? And this point here was at 4, 3. 4, 3. Okay, so we're going to find the domain and range of this goofy little function I've drawn here. Okay, so domain, we said, were all the possible x values. The domain of this function, which we're just going to abbreviate with a D, the domain of this function, how far to the left does it go? The leftmost point, its x value is -3. And we have a closed circle here, meaning we actually do touch this point. We actually touch the x value of -3. So here I'm going to put a bracket, because I actually touch it. That's going to relate to a closed circle, -3. And then we keep cruising along. How far to the right do we go? How far to the right do we go? We go all the way up to 4, but not actually touching 4. That's what that open circle means. It means we didn't actually touch it. So we went from -3 almost as close as we possibly could to 4. So -3 with a bracket, because we touched it with a closed circle, comma, means we're going up to 4, but we didn't actually touch it here, so we have a parentheses. So again, bracket, I'm going to go with a closed circle when you actually touch that value, parentheses when you don't actually touch that value. Okay, now let's look at the range of this function. Range is in the up and down direction. Range is the y's. What is the lowest we ever get to here? The lowest we get to on this function is -2, and that was a closed circle, so we actually touched it. So we're going to use a bracket. -2. And what's the highest we ever get to? Highest value we get to is 3, but not exactly, because it's an open circle, meaning we don't actually touch it. So we get as close as we possibly can to 3 and use a parentheses. Okay, so we found the domain, we found the range, and we used our interval notation. See, I told you it's beautiful, right? It's very, very gorgeous. All right, let's do another example. Okay, so let's draw a graph again. Might give myself a little bit more space to work here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 4. 1, 2, 3. Okay, not too much bigger, but it's a little bit bigger. All right, let's put an open circle. Let's start with an open circle this time. Let's do an open circle at -5, -4. -5, -4. Let's put a closed circle at -2, -1. Okay, again, I'm going to label these points. -5, -4. This was at -2, -1. And you can draw a straight line between, you can draw a wriggly line between, as long as it doesn't go above or below those dots. Great. And then we're going to skip over here and let's do a dot. Let's do a closed circle at 3, 0. Closed circle at 3, 0. 3, 0. And let's do an open circle at, what was this, 6, 2. Let's do 6, 2. Open circle at 6, 2. And connect those. All right. This is at 6, 2. Okay, so let's talk about the domain and range of this piecewise function. It's got two separate components to it over here and over here. All right, so the domain of this piecewise function. How far to the left do we ever go? The leftest we ever get is -5, but not exactly because it's an open circle, right? So that means we want an open parentheses, -5. Up to, well, we go up to -2 when we actually touch it. It's a closed circle. So up to -2 with a bracket. And we have another part to this. So we also have a domain for this piece of this piecewise function. So we're going to say this U symbol, that means and, because we have a domain for this part and we have a domain for this part. And both of them are valid and need to be notated as such. So in this second piece, we go from, what is the x value here? Well, it's 3. We actually touch it. It's a closed circle, so we're going from 3 up to 6. 6 that we don't touch, so that'll be a parentheses. So 3 up to 6. Open parentheses. This was a bracket because we actually touched the 3. This is a parentheses because we had an open circle at the 6. And again, that U meant and. We had a domain for this part and a domain for this part. All right, let's look at the range. Range up and down, possible y values. What's the lowest we ever get? -4, but not quite because it's an open circle. So we're going to use an open parentheses there, -4, up to, we get up to -1, and we actually touch it because it's closed. -1, close that guy. And we have a range for this piece. So, and we go from 0 to 2. 0 we actually touch, 2 we don't. So 0 to 2. All right. Main takeaway of this example, U means and. When you have multiple components to your function, you have to talk about the domain and range of all parts. So you combine those domain and ranges with an and or the U symbol here. All right, let's check out another example of a function that you've seen before. There we go, paper's looking good. So let's draw our x and y axes. I'm not even gonna, well, that's a rough looking x-axis, but it's all good. Let's put on there our quadratic function, a parabola. Whee! All right, so this function, our f of x here, is x squared. And let's find the domain and range of this function. Okay, domain of the function. How far left, how far right do we go? Well, remember these arrows mean they continue on in this direction forever. So if we're trying to see how far to the left does this graph go, this arrow indicates I'm going to continue in this direction forever. So as I go up, I keep going to the left forever. Forever, never, 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 never. What's the leftist most number? I'm using quotes here for a reason. The leftist most number there is, that would be negative infinity. Negative infinity, which is not technically a number. We can't actually touch it. So we're going to go from negative infinity to what's happening here. What's the rightest most number, again, quotes we're going to get to? Well, this keeps going to the right literally forever, so we're going to be approaching positive infinity. And again, those are numbers. Those are concepts. Infinity and negative infinity, those are concepts. We cannot touch them in a number sense, so we want to use open parentheses here. Okay. And how about the range? The range for this function. That's all the possible y values in the up and down direction. What is the lowest we ever get on this graph? The lowest we get is 0. The lowest y value you're going to get is 0, and you actually touch 0. 0 is part of this function as a y value. Remember, this guy goes through the origin at 0, 0. So we actually touch 0. We're going to go from 0 to, what's the highest y value we're ever going to get? Well, both of these parts go up forever, which means we're going up to, in the y direction, positive infinity. Again, we can't touch that, so we use a parentheses. So our domain, in the left and right direction, we're going to the left forever, to the right forever. That's negative infinity to positive infinity. There's another way you can say that. Negative infinity to positive infinity, that is all real numbers. So we could have also said all real numbers, which has a special symbol like this. That means all real numbers. All real numbers. You may remember there are these things called imaginary numbers that have I in them. We're not talking about those. We're talking about all real numbers. All right. Fabulous. All right, let's do one last example. Let's draw our axes. Again, I'm not going to label anything. I'm going to put a cubic function on here. Our cubic function. That's f of x is equal to x cubed. X cubed. Let's talk about the domain. Left and right. How far to the left do we go? Well, this arrow says we're going to keep going down and to the left forever. Forever in the left direction means negative infinity for the domain. So we're going to go from negative infinity to, in the right direction, we keep going up and to the right forever. So this is going to go to positive infinity. Range for this one, up and down direction. How far down do we go? Well, this arrow says we're going to keep going to the left and down forever. So we're going to approach negative infinity. And how far up do we go? Well, this arrow says we're going to keep going to the right and up forever. So we're going to positive infinity. Which means both of these could have also been all real numbers. All real numbers. All right, let's recap real quick. What did we talk about? In first pre-calculus lesson, we talked about what are domain and range. Domain is all possible x values in the left and right direction. range all possible y values, up, down direction. Then we talked about using interval notation. Use a bracket when you actually touch a value that would correspond to a closed circle. Use a parentheses when you don't actually touch a value, aka an open circle, or as we just talked about, infinity. If you have multiple parts to your function, you need to talk about the domain and range of all parts of those functions and join them with this little u here. And lastly, we talked about functions that have domains and ranges of all real numbers in some cases. All real numbers meaning going from negative infinity to positive infinity. All right, scholars, that's it. Congratulations, you made it. Love you so much. I'll see you next time. Keep on that hustle.